So now today I'm going to begin the new chapter or the new unit, which is characteristics of functions. So here I want to introduce some concepts. Namely, we have operations with functions. And that means when you have two functions or more than two functions, 2, 3, when you have a bunch of functions, you can combine them in certain ways. For example, you can add or subtract functions. You can multiply functions. And most importantly, you can compose two functions. So this composition, I believe, is something new for you. So you know, whenever you have, so suppose that we have two functions, f and g. So we want to make a new function or construct a new function. I call it h. So I defined it to be f plus g. And f plus g of x is defined to be just f of x plus g of x. So this is the addition. Or sum of two functions. Okay. So here is sum of two functions. You can also multiply the product of two functions. F times g of x is defined by just pointwise multiplication. This is called pointwise multiplication. Pointwise means at each point, f times g is equal to, at each point x is f of x times each of x. So this is called pointwise multiplication or product. Moreover, if you have any function like f, you can multiply it by a number, constant number. So like if k is a constant number or c is a constant number, so c, it is again, this is called a scalar multiplication. It's like whenever you have a function f of x, you can define 2 times f of x. You can define 10 times f of x. In particular, you can define minus times f of x, minus 1 times f of x. And once you define minus times f of x, then you can subtract functions because you know how to add two functions. So f minus g is just f plus minus 1 times g. Okay. So far we have sum of two functions, subtraction, multiplication, and multiplication by a scalar. But I mean, one of the most important ones are compositions. So how to compose two functions. And the picture you should have in mind is that, so you have a function like f, it takes x2, like say y, and there is another function that takes y, to say g, takes y to z. Here we say that z is equal to g of f of x, which is equal to g of y. So let me draw another picture that might be helpful. So imagine we have a bunch of numbers in the domain of f, like 2, 3, 5, and 2 goes to 1, 3 goes to -1, and 5 also goes to -1, and g takes 1 to 2 and -1 to 10. Then based on this picture, we can say that g, and there is another notation. Let me also write it on the top. We also use this notation g o f. So g o f of x is just equal to g of f of x. So look at the picture, the last picture. So what is g o f of 2? So that means you have to first take f. So f takes 2 to 1. So this is equal to, by definition, g o f of 2 is just g of f of 2, which is equal to, now, what is f of 2? F of 2 is 1, so it's g of 1. So g of 1 is equal to, what is it? Based on this picture.
2.
2. So, or just let me put this -5, -8. I don't want to use similar numbers. Okay. Okay, so that would be, if I use this -8, so g of 1 is equal to -8. Now I ask you, what is g o f of, what is g o f of 5? So g o f of 5 is by definition g of f of 5. So this is equal to g of, what is f of 5? So f of 5 is -1. So this is equal to g of -1, which is equal to 10. Right? So in general, if you have two functions, like f of x and g of x, we can combine them and define the new function, say g of f, which is by definition is equal to g of f of x. We can also do f of g, but remember that these two are not equal to each other. These are two different functions, because the first one, you first act f and then first act g. But the second one, you first take g and then you take f. So f of g of x is by definition f of g of x. So these two are not equal to each other in general. So example. So imagine that f of x is equal to 3x plus 1 and g of x is equal to 2x squared minus x plus 1. So compute g of f of x and f of g of x. So just by definition, g of f of x is equal to g of f of x. But f of x is 3x plus 1. So it's g of 3x plus 1, which is equal to you just have to plug in this to g. So this would be, because g of x is 2 times x squared minus x plus 1. So what is g of 3x plus 1? So it would be 2 times what? 2 times 3x plus 1 squared minus 3x plus 1 plus 1. And now 3x plus 1 squared would be 9x squared. When you multiply it by 2, so you get 18x squared. And then you have 6x times 2, 12x, minus 3, you have plus 9x, right? Because 3x plus 1 squared gives you 6x, and then you multiply by 2, it becomes 12x minus 3x is 9x, and then you have plus 1 times 2 is just 2, and then minus 1 plus 1 is just 2. Okay, so it's just a matter of some computations. So far, it's not actually a deep problem, but the concept is deep. This concept is deep.
Okay.
And there are several things you have to be careful about. One thing is that, so when you compose two functions, you have to make sure that g of x is in the domain of f of x. Okay? So for example, if you have, like, imagine that f of x is equal to a square root of x. Here, there are some restrictions. We know that the domain of F is the set of positive numbers, or numbers greater than or equal to 0. So if you have g of x equal to minus x squared minus 4, then f o g, what is f o g? F o g of x is a square root of, so by definition is f of g of x, which is equal to a square root of g of x, right? And that is equal to a square root of minus x squared minus 4. But this guy, minus x squared minus 4, is always less than negative 4. So this doesn't make sense. Right? Because g of x minus x squared minus 4 is something like this. So it's always less than negative 4. So you cannot apply square root to this function. So it's obvious that g of x is always less than or equal to negative 4. So a square root of g doesn't make sense. So you have to be careful about domains and restrictions when you combine or compose two functions. Okay. So another thing I want to talk about a little bit is the concept of a one-to-one function. So one-to-one, or sometimes it's called injective functions. So a function is said to be one-to-one if there are no two values of x with equal y values. Okay, so f of x is said to be one-to-one if there are no distinct x1 and x2 with f of x1 equal to f of x2. So you cannot have two different x with equal y values. So then if this happens, it's not one-to-one. Okay, so for example, if you have like x squared plus 1 or x squared or anything like this, this is obviously not one-to-one, right? But if you have a function like this, this one is 1-to-1. And how you can tell that? So this is, so I call this F, I call this G. So F is not 1-to-1. But G is 1-to-1. And how you can tell? And one way, so as you see, for example, in this picture, so you have for F, look at F. So if you, so look at this, for example, 2 points. So these 2 points on the graph of F, they have 2 different x, but equal y. So one way, we call it maybe test, horizontal lines test, is that you draw horizontal lines, and if any horizontal line crosses the graph at more than 1 point, then it's not 1-to-1. So you draw horizontal line. If you have even one horizontal line that crosses the graph at more than 1 point, then it's not 1-to-1. Otherwise, it is 1-to-1. So you see the picture of G. So if you have any horizontal line, if you draw any horizontal line, it crosses G, or it meets G, the graph of G, at most 1 point. Not, but for F, you can have many horizontal lines that meets the graph of F at more than 1 point. Okay, so obviously, so this function f of x is equal to x squared, or say x squared plus 1, is not 1-to-1. Why? Because you just need to give me one example. For example, f of 1 is equal to 2, but f of -1 is also equal to 2. So that means f takes 1 and -1 to the same number. And that's why, which is not 1-to-1. Okay. So a key point about 1-to-1 function is that if a function is 1-to-1, then it has an inverse. So if f is 1-to-1, then it has an inverse. And how the inverse is defined, the inverse is defined very, I mean, if you want to visualize, it's simple, the definition of inverse. If you have a function like f, Then F inverse, so if, for example, you have a bunch of numbers in the domain of F, like 2, 4, 5, and so on. So F takes 2, for example, to 1, and takes 4 to 3, takes 5 to -10. The inverse, you just flip this arrow. So the inverse of F so how the inverse defined is that, so the inverse just goes in the opposite direction. So that means F of 2, for example, here is 1. So F inverse of 1 is equal to 2. So you basically flip X and Y values. Or when you say F of 4 is equal to 3, then F inverse of 3 is equal to 4. And F of 5 is equal to -10. That means F inverse of -10 is equal to 5. So in general, and this is very important, you have to keep this formula. Is a very important formula. In general, we say that if Y is equal to F of X, if and only if X equal to F inverse of Y. It's like this, F of 2 is 1, then F inverse of 1 is 2. So Y is equal to F of X, if and only if X is equal to F inverse of Y. This is super important. And that this is how we basically, so for some questions, you saw this before. For some question, they want you to find a formula for the inverse function. Okay? And you have to use this. This is the guiding principle. This red formula in the box. So for example, find the inverse . So example, find the inverse function for, so imagine F of X is equal to X plus 1 over X minus 1. So for this type of question, so what we usually do, what we do is we begin by saying that, okay, Y is equal to X plus 1 over X minus 1, and we try to solve for X. We try to find X in terms of Y. So that means X minus 1 times Y is equal to X plus 1. So that means xy minus y is equal to x plus 1. So that means xy minus x is equal to y plus 1. So that means x times y minus 1 is equal to y plus 1. So that means x is y plus 1 over y minus 1. And this is equal to F inverse of y. So if you want to write F inverse in terms of x, then F inverse of x, so as a formula in terms of x, then f inverse of x would be x plus 1 over x minus 1. It's funny. It's a function which is its own inverse. So inverse and the function are equal. It's a coincidence here. Okay. Yeah, so for computing the inverse, it's important that the function needs to be one-to-one. But here I give you some exercise. So you don't, for doing this, first, you don't have to be worried about one-to-oneness. So you don't worry if the function is not one-to-one. Just try to find a formula for the inverse. Okay, but I will discuss it in details. The matter that a function, whenever the function is not one-to-one. Okay, so here is the exercise. Your homework is find the inverse of a f of x. So we start with some simple question. 2x minus 1. B, f of x is x squared plus x plus 2. C, f of x is square root of x minus 1. D, f of x is equal to 2x minus 1 over 1 minus x. E, f of x is equal to the square root of x squared plus x plus 1.